Today we are going to talk about hypothesis testing. First of all, when you have a title, you have to know what does it mean, the words in the title, because it is key for this one. We know the hypothesis is like the word assumption. Okay, so you assume something. But for mathematician, I don't like assumption because I can call it conjecture. Conjecture, it means in Arabic, you claim something, right? You have a claim, something. Idda'a, okay? So you claim something or you assume something, okay? So okay. So you would like to test it, right? Testing your claim, right? So testing for testing, okay? You test the assumption to know it is right or wrong. Okay, this is our title. Okay, so I would like to go for conjecture. Some people like claim, some people they call it assumption, some people they call it hypothesis as it is, right? Okay, so we have hypothesis. How many types of claim or hypothesis we have? We have two types of hypothesis. One called null hypothesis. From the word null, it means nothing. You do nothing. You're just claiming, like saying so and so and so. Okay, so they have a notation H naught or H null, right? Okay, so you claim Osama is a good teacher. Okay. Okay, you have another one called alternative. And from the name, alternative for the hypothesis, right? So the alternative notation is called HA. And this is, we call it H naught. Okay, HA will be opposite to this one. So I'm saying Osama is not a good teacher. Okay, so what you are going to do to test this one? So this is a claim. Okay, you would like to test this one. Okay, we will go for steps to test any hypothesis. First step, step one, write the claim. Write H naught and HA, the null hypothesis and the alternative hypothesis. Okay. Some people they call it H1. I don't mind if you call it H1. Okay. But I prefer to have a word just referring to the name of this one. So H1, it will not give me any indication for the concept, but HA give me the first letter from the alternative hypothesis. So I'm going to write the hypothesis. Step 2, you just write or your level of significance. What is the level of significance? It is alpha. Yes, we know it is alpha. So you have to determine your alpha. Your alpha is equal the interval confidence or confidence of interval minus what? Yes, minus alpha. Okay. Sorry, 100 minus the sorry, equal to 100% minus the interval confidence. This is alpha. So I have to specify my level of significance. You may be given the level of significance or you may be given the interval of confidence. If you get this one or get this one, you know the alpha. Okay. And now up to this one, you will find the critical value. Use it. Oh, before this one, step 3, find the critical value. Could be value or values. I'm explaining to you later on. Up to alpha. Okay. Step 4, find the statistical value. Find the stat value. Okay. Up to the formula. Up to the test formula. Now, all of these one, you should have the last one to take the decision, right? So step 5 comes late. This is for this decision. You compare the critical value. I will call it XC, and I call this one X. O. They call it O for observed, or S, it doesn't matter. So you compare XC with your X O or your X.
What is XC and what is XO?
XC, it means critical, coming from the word critical, right? Okay. And the statistical value, stat value, so you call it XC, right? Catch it?
Yes.
So you compare XC with a critical value with a statistical value, right? And we know we have to graph a little bit of graph here, and you will find the critical value here. And if you have two critical value, you have another one here. And this is, we call it the acceptance area, or the acceptance. And this is, we call it the rejection area, as we used to. This is the rejection area. Rejection for what? Rejection for H naught. Rejection for H naught. So once you reject H naught, you will accept HA. After you finish and compare, and you said you will accept which one, finally you write a summary. Just you transfer, or sorry, translate step 5 into a conclusion, right? Again, how to do any test? Step number 1, you do for what? You write the null hypothesis, this is very important. This is why I'm repeated many times, right? H naught, and also write the alternative hypothesis. HA. So this is the first thing you go. Step 2, I will choose a nice color for you. Step 2, You do what? Yes, you go for determine the level of significance. Level of significance, all the time I call it the accepted error, you know? What is the percentage you accept to have an error, right? The level of significance, this one, we call it alpha, right? The level of, if you are not given alpha straightforward, you are given the interval of confidence, the confidence. Interval. So if you are given the confidence interval, so you got 100% minus this one, all of this 1%. Okay, so you get the percentage for this one. Okay. Now you know the alpha up to. Okay, choose different color. Maybe this is good. Up to alpha, find using the stat table fit for your test the critical value, so we know the critical value found by the table, stat table for the right test. Okay, if it's a Z test, we use Z table. T test, we use T table. Chi-square test, we go for chi-square table. F test, we go for F table, and we will see this one in details, right? So the critical value, XC, I call it XC. Sometimes you have only one critical value, and sometimes you have more than one value, right? So if you have one, okay. If you have two, that's okay. Once you have the critical value, the next step you will go for the stat value. Find the stat value okay. The statistic value is only 1, but the critical value could be 1 and could be 2, right? So the stat value up to your test formula. Okay. Now, can anyone take a screenshot and put in the chat, please, to go to the next page? Okay. Now, step 5, you have to make a decision. To make a decision, what is the decision? Accept H naught or reject H naught. If you accept H naught, it means you reject the alternative hypothesis. If you reject the null hypothesis, it means you accept the alternative hypothesis. This is what does it mean. How to make the decision? Yes, you take a decision by comparing. To make the decision, you have two choices. By comparing the critical value or the statistic value from your formula by with the critical value. Okay, and you may have a little graph like this one. Okay, if you have a right tail, this is what we call it, right tail test. Why we call it right tail? Because if you have the alternative hypothesis something greater than something else, so you go for the right test. What about if you have only left test? In this case, your alternative hypothesis will be something less than something else. What about two-tailed test? Yes, if I have not equal or equal in the alternative hypothesis, so your alternative hypothesis has something not equal to something else. So we call this one two-tailed test. Two-tail test. And this is right tail, and we call this one left tail. So what is the shaded area? Yes, the shaded area, this one, we call it what? Here, if this is the critical value, this is the critical value, I have only one in this case. Okay. Okay, and here you have one. Here I have two, x critical value to the left and another critical value to the right. Okay. Now, if your critical value, your stat value coming here, x is stat coming in the rejection area, so you reject H naught. But if your stat value coming in or anywhere here, you accept your alternative null hypothesis, right? Very similar to this one here or this one here, right? So this is the acceptance area. Okay, this is the accept H naught, but the shaded area is the rejection. Okay, it's the rejection area for H, the null hypothesis. This is what we call it right tail test. This is what we call it left. If you have not equal, you go for two tail tests. Okay. And what else? If you compare this two, that's fine. But there is another one by comparing what? Yes, I got this one, I think.
Doctor?
Just a minute, please.
Okay.
By comparing the p-value with alpha value. You may ask, what does it mean p-value? The p-value is the probability of whatever it is less than stat value. Okay, and I think this is the most popular one, especially when you are using the software, right? So you have two ways of comparing the critical value with the stat value just to have the decision for rejecting or accepting this one. Once you finish all of this one, you just write a summary. Okay. Ask your question, please.
Doctor, the meeting is locked or?
No, it's not locked.
Because Maha can't join.
Maha can chat me, please. Okay.
Oh. Can I send her a request or?
Sure. Okay. Is it okay now? Let's start with, I'm repeating all the time. I'm repeating these steps because all the time you will go for the same steps, right? So what we have to mention again and again and again, hypothesis testing. We know what does it mean, hypothesis testing, and how we do, what is the steps for this one? To do what? Yes, the first one we will start with the hypothesis testing to compare mean, or population mean if you like. Compare population mean. If we have population mean or means, so we go for this one. And what else? We have to, the same thing, just to compare what? To compare the variance. To compare the population. When I'm saying variance, it means the standard deviation square. Population variance or standard deviation, because it's the same technique, but you're just having the root square. Standard deviation. What else we can do? Not only to compare the population mean or to compare the variance, we can compare the proportion. Okay, we can test the proportion as well, right? To compare the proportion. But I will keep this one for later on, okay? Also, we can test what? We can test the regression also. We can test the regression, okay? This is what we are going to do later on. But now we go for the comparing mean and to compare the variance or the standard deviation, okay? So let's go for what is the test for to compare the mean. Or means. We have two types of test here. The first one, we call it Z-test. And the other one, we call it T-test. As you remember, when you are going to use this one, yes, I hear you when you're saying when the sample size, greater than what? Can I hear you again?
30.
30, thank you. Because using the central limit theorem, this one will be close to the normal distribution. This is the point why they choose this one. But the central limit theorem says when n is so big, right? Okay, fine. And when, this is the first case. The second case, when we do what? Yes, I hear you. When the population variance or standard deviation
Is unknown.
is known, not unknown.
Oh, is known.
Yes, okay, thank you. Is known. What is the notation for the variance? It is sigma square. For the standard deviation, we use sigma, right? Okay, that's good. Now we know the other cases is what? N is sample size is greater than 30, so it is fair enough to go in the other side and say we are going to use something else. If n, the sample size, we call it n, so the sample size n will be less than 30. This is the first case. And the second case, when sigma or sigma square is unknown. Fine? That's good. We'll go for the example after we take a break for the prayer and come back inshallah after 10 minutes. Is it okay?
Yes, doctor.
Yes, doctor.
Okay, thank you. See you after 10 minutes.